Hello and welcome to the next chapter actually called Native Application Development, and this is something Quarkus can provide. So the idea of the native development is that instead of Java, instead of the Java code that you produce by your backend, you convert whole your app, whole your backend, whole your Quarkus application into native image, which provides dramatic effect on startup time and execution time, because everything it's literally, there is no Java at all in some sort of way. This is literally bytecode. So you have a bytecode instead of the Java code that is executed on virtual machine. In our case, we have just a bytecode that you put on machine, run it as a normal executable, and you see the results basically. So, but firstly, before we start this whole topic, we'll need to install a few dependencies. So this in this video, you'll see how to install the GraalVM, which I was talking previously a little bit. So the GraalVM is basically a polyglot, not even a virtual machine, the development environment, which can give you, for example, with GraalVM, you can execute JavaScript code from Java and vice versa. So you can call Java from JavaScript, or Python or R from any other language. So we need this. The other thing that GraalVM provides is building native images, and this is exactly what Quarkus uses. So we'll need to have install Graal Community Edition, GraalVM Community Edition Java 8. So we'll use a brew. So if you don't know how to use a brew, just look at the comments. I'll give you a link to how to install it, right? So let's execute broadcast install GraalVM tab GraalVM Community Edition Java 8. All right, so it's downloaded. It took around 20 minutes, so keep your time. And it also asked me to put my password, so I'll do that. Okay, so you can see that Grpc Java 8 was successfully installed, and it also shows you that to use GraalVM Community Edition, you may want to change your Java home, which is supposed to be export Java home, to this part. So let's do it as well. Vim and then dash profile, I think. So we can put here, I have here some of the stuff, but let's use the, actually I prefer to use aliases like this, GG. Let's make it like this, so we can put it, so I can switch Java homes from time to time. So basically I'll do the GG, and it will be aliased as export Java home to specific option, which will be used later as I want it basically. So yeah, let's write it like this. And it also says you may want to add its bin directory to your path, so we can use the GU, which will be also a good idea. So this one we will just put it as is. So we'll export everything that is here like this. So this should be enough. Yeah. So let's use a source like this, bash profile, and so we can put a GG like this, and we have Java version will be the GraalVM 20 Community Edition. That's exactly what we want. So now we also should have the GU command, so GraalVM component updater. So we need to call the GU install native image. This will help us to create a native image from the Java project basically. It will take a little bit as well, but not so long as the GraalVM itself. So in your case, as I showed you previously, so you can go open Vim, bash profile. So in your case, if you want to always use this like all the time, you can just use the so you can, instead of the GG, you can put it like this and then delete this line. So like this. So you export the Java home to be the home of like the default Java home will be GraalVM, and then the export path will be also for the let's say the tools that you can use as well, but it depends. So you can just not use it if you want, but I prefer to use it my way. That's so you can like alias and then switch between environments if you need to, really easy. So I have G8, G12, and GG in our case will be Java Graal if needed. Okay, so yeah, so let's close it for now, and you can see that it's already installed. So yeah, that's basically it. Now we'll proceed. In next video you'll see how to do it in Linux. So the other thing that you might want to call as well is the Xcode select install to get all the requirement like executables to build the native image. So you will like to, so the firstly, yeah, you'll need to probably install all the requirements here with this command. So in this video you will see what the native image is and how to use it. So the idea of the native application or the native image is that you want to have some executable that is really native. That means that you can execute it. So for example, like find, right? So find or something like this, which will be really fast, right? So like this. So you don't want to firstly call the java -jar and then some app jar, right? Like this. So this command doesn't just, you know, opens the app.jar and then executes the code. No, this will bootstrap the Java virtual machine. This will analyze all the code, prepare it, and then only start. So when you start the Quarkus application via the Java JDK, this takes also a while, from a few seconds in some cases. And if it's a really large application, it will take like great 20 seconds, maybe 10, depending. Yeah, if you use Spring, this can take on this machine, on this what is this, MacBook Pro 15, this will take like 10 seconds to have like a Spring with GPA and some, you know, some classes as well. So yeah, you only want to use it like this, use like app, right? /app, and that's it. So this is not like this is not, you know, it's not like super problematic to use this /app, right? The problem occurs is when you count the startup time and the amount that image waits. So with Quarkus native applications, the jar itself will take less space. That's the first thing. The second is that the footprint of the memory will be drastically smaller, so the memory size of the app will be a lot smaller, and you don't need to have a JVM as it is. That's the third part. And then the fourth actually is the speed of the app. It will be a lot faster because the code is already analyzed and it's just a bytecode. So you just run this app and it's a lot faster than, you know, using the JVM. But the accent here is that this app will run like drastically faster. So it's like 5 milliseconds or something like this, comparing to a few seconds. If you use lambdas or cloud, like the cloud applications, for example, right? You want the startup time be as small as possible, because when you use, for example, we'll look at the Kubernetes later. So in Kubernetes, you want to have your pods, your services starting up as fast as possible, so that you don't have like you know, the downtime. Or if you have seamless updates, in this case, you want to switch from one app to other as invisible as possible. So you won't just, like, you know, you have one app, switch and you have the second one. So the GraalVM provides it, and the Quarkus itself provides this. So, and we will look today how to use it, basically, how to take advantage of it. And yeah, so the first thing that you need to have actually is to have an active Docker environment up and running. So please have a look at the documents. Maybe I have a video about it. I'm not sure if it will. So I use the version 2.1.04. I think it's a little bit outdated, but whatever. So as long as you have some, just you can download it from the Docker website and install it. There should be any problems on any machine, basically. So yeah, so that's the first thing. Let's create our app, and we'll use, actually have here already predefined something. Let's use this that we used for reactive roads, but this time it will be a native image, something like this, right? And let's use it. Let's call it from here. So this will create our app. There is nothing, we'll just show you how it works. Okay, so we opened our project, and the first thing that you would like to look is Maven POM.xml, right? So in our case, that's a default one that you've seen multiple times, but we're interested in one thing, that we have the profile here, right? So we have profiles, profile native, and the activation property native. So this thing will help you to create a native image, and you actually don't need to do anything here. So there is like an integration test as well for here in the package type native. So so yeah, you have this property here that will help Quarkus to understand what's going on. And so how to execute it, that's super easy. So the first thing is, let's actually use the other terminal option here. So let's go to the native image, right? So we have in the native image project, you can see that it's default one, nothing special here. So one thing that you can do is call first check your Java version. It should be, in my case, so it's GraalVM, as you can see, right? What you can do here, so in previous video, if you followed my steps, you can use the GG in our case, so you can post the G8 or something like this. But GG will activate our correct Java environment. So, and you can see that Java version is basically OpenJDK 64-bit GraalVM, right? So you need to have GraalVM. Of course, you need to have a Docker running. So like this, I have a MariaDB here always. And yeah, so let's build our first image, actually, Maven and Vim. Let's call it and then package, and then minus profile native. So this is it, nothing more, nothing less. So to build a native image, you only need to run this command, and it will take everything from here. But be ready that it may take a little bit longer, because the idea of a native image is that it analyzes everything that you have in your app, and not only in the app. It will look at all the dependencies that you have, all the libraries, all the JDK information inside. Okay, so it's finished. It's Quarkus augmentation, right? So you might hear more noises than usual, because to support the native compilation, I'll need to make my fans a little bit louder to support all the stuff going on with my machine. But I hope this will be tolerable from your side. Sorry in advance, basically. As I said, yeah. So the idea is that you can see that total, it augmented or looked through everything, and it was like 4 and 3 gigabytes, and then took 65 seconds, right? So you can see here. And so you can see that it takes everything. It looks at the objects, type flow, features, analysis, and everything that's basically it. So it goes through every class, every file, basically, and checks it. And it sees if there is, like, if you call it anywhere, like even if you, so you basically, that's a good example. So if you go to git greeting resource, you return a string, right? What is a string, basically? You go to the string class, and then there is a serializable, comparable, char sequence, and looks at all of them, and checks the bytes and all this stuff basically, right? So it takes a lot of time, but the idea is that you compromise, you allow basically to make it longer to build but faster to run. So yeah, so let's actually run it, right? So we have it. You can go to the target, cd target, and you can see here that we have a native image 1.0 snapshot jar, and then actually, yeah, native image 1.0 snapshot runner, right? So we have it. Let's actually also create a Maven package, just a package to have a, oh, I think it's actually our package jar, but let's rebuild it just in case. Maybe it's different from what we had. So yeah, let's create a Maven package as well. So this one, you can see that it takes a lot faster to build. So it runs the test, it checks, and yeah, so it took 7 seconds comparing to 63 or something seconds that was there, right? But let's go to the target folder, right? And so you can see that we have native image 1.0 snapshot jar, right? Like this one. Runner actually. So we have native image 1.0 snapshot runner jar, and then we have this thing without the dot something, right? So that's the native image, even though we have a native image name, but it's the name of the project, don't forget about this. So let's run our first native image 1.0 snapshot jar, runner.jar, right? Like, that's not correct. Oh yeah, java minus jar, native image snapshot runner jar, like this, right? So you can see it started and it took in 0.6 seconds, and so it's like almost a second, right? So yeah, so it took 7 seconds to build, 0.6 seconds to run. Let's compare it to the runner. So runner took us almost more than a minute, right? So let's just, so the first thing, as you can see, is basically your whole /native image 1.0 snapshot runner, like this. And you just saw the huge difference in the startup time. So you even, so it's basically, I just press return and it's there. So it took, first time it took 0.055 seconds, or I think it's 55 milliseconds. And then the second time you run, you have already cache. So it took 0.013 seconds, right? So it's like 14 milliseconds, right? Yeah, and it's you can go to the 8080, of course. So we can go to Grossman 8080, and not put actually, but so yeah, 8080, and then hello. You can see that it's working as it was working before, right? So yeah, so this is the native image. And you can see it's working pretty similar, nothing special here. And of course, if you run the Java minus jar, let's see, it's actually took 0.7 seconds this time, and then you run it one more time, it's basically 0.6. So there is no difference, right? You run it once, twice, it's almost the same. Comparing to the Quarkus, it's like, you know, and because of this 0.014 seconds, so it's 40 milliseconds to, you know, to start the whole backend. You don't need to wait anything. It's, of course, there is like no GPA or something like this, but still it's impressive. And because of this, you can do pretty much, you know, the bots, or like use a Lambda, AWS Lambda or something like this, right? Or create a really scale super fastly your backend. Like, I don't know, if you have the Kubernetes and you want to duplicate the pods, amount of pods, so you can spread the load balance and load balance your app. This takes like, you know, you can see it's like really fast. So, and it's really enjoyable to run it actually. Like, you see how fast it is. It's like insanely fast. So yeah, and the stop time actually also, the shutdown time is also faster than in where is it? Let me find. Here you can see that when you stop it, it takes more than in the native image, of course. So yeah, that's not all. So this image is actually mostly binded to Unix, or maybe macOS. Haven't tested it yet, but maybe we can test it in the future. So if you want independable executable, right? So you can create a native image, but you want to be sure that it will work on, for example, some other environment, or maybe in Docker. So Quarkus also took this into the accounts, right? And you can run next command. Let's actually go back and declare -d Quarkus native container build equals true, basically. So with this command, Quarkus will build and test your image not on your computer, but rather on the Docker environment. There is also a way to use a Podman, I think, but we will use Docker, so there's no difference in this. So once you run this command, this will build a native image in Docker image that you have here in IntelliJ IDEA, the Docker GVM, actually Docker native. So it will use this one for testing and building. So you can see actually there is like Maven package profile native. So it's basically what we described previously, right? So let's go back to the, let me actually a little bit better. We can look in it. So you can see that there is a Red Hat registry called UB minimal 8.1, which is specifically created for native images. So there's the minimal, so you can start it really fast and stop it really fast. And there's like the work to work, and then you copy the runner to the work application, and then you chmod it and expose the 8080 port, and then user is 1001, and the command is /application Quarkus host 0000. So yeah, so let's build firstly our native application, and yeah, it will again take a little bit longer than you might expect. So we are building, it's not building in on our machine, right? Not on my Mac. It's basically building in a container. And yeah, so you need to know Docker, so please have a look if you don't know what it is for this chapter. But it's also optional if you won't use Docker or native images, but you might need it for like even Kubernetes needs the Docker. So if you're a backend developer, Docker is like must have. So yeah, let us build this image a little bit. Let's wait. So something interesting started. I'll record it as well. So you can see that it's running Docker run, and basically there's a lot of parameters, but it's basically started the container, as you can understand, with the Docker run command. And you have an output also here, so you can see how long will it take and how basically much time it will take. And so it's basically almost the same, but you can see that there is like Docker run because we used the command called the Quarkus native container build. So it will build in a container, and yeah, let's wait a little bit. I think it actually already almost finished. This time actually it was a lot faster, as you can see, although maybe not, maybe it's also 60 seconds. Let's see. All right, so this time it took a little bit longer. So here is the 85 seconds and the augmentation completed in 159 seconds, which is a little bit more than like a normal native build. But this has its own benefits, basically, because this image was built in dependable environment, so it won't depend. It's not correct to say like platform agnostic, right? It's not like the GVM that will be you have a different implementations for each system. Rather, you build it each time on this UB minimal image, and because of this, let's say you have 3 developers, right? One is working on, for example, let's say macOS, right, on the Mac. The second one working on Linux, and then the third one is working on the Windows, although I'm not sure if it's possible to build a native image in Windows, but yeah, so let's say you have 2 developers which works on macOS and then Linux, and there is so many different Linux images, right? And so you run it once on one machine, you run it next time on the macOS, and then maybe you always was running it from macOS or Linux for the, I don't know, year, and then somehow you upgrade your Mac, and then you use it in Maven build -p native, and it's like, wow, what's going on? Maybe there will be some issues or something like this. So this will help you basically not to for such problems not to occur, right? So this will be always the same. This will be always same image that you use. You build the image on the same environment and you run it on the same environment. So you can see that you can run the container using docker run -c -rm -p 8080 Quarkus native image. So one more thing that we need to do is actually to build the image itself. So the way it works for the native build, for the container build, is that it creates a container, it builds the app, the native image, the native application, and then it removes the container itself because you don't need it. So one thing that you need to do is to do it like this: docker build -file, docker file native, and Quarkus native image, and then dot. So that's it. So you just run it from the project folder like this, and it will take not so much, but you'll need to load some of the images like the UB minimal itself. Yeah, so we created our app, as you can see. So we have built and the native image latest itself was created. So yeah, so let's run the docker run -rm -p 8080 Quarkus native image, right? So now it will start, and you can see that it started. Also, not so much the difference, 0.012 seconds. I think it was the same, although I might be wrong. And you can of course go to Postman, call /hello, and you can see that it's working as it was working before, but it's already in Docker image. So with this action, you can see that you basically haven't done anything, right? So you created, there is already everything predefined. So you see that we haven't changed any file, right? You can see that this is basically as it is. Nothing was used here different than it was, right? So you can see that the Docker native itself is the same. So everything basically is provided by Quarkus. You just need to run through commands, which is actually specified for you in description of the files. And yeah, so just if you want to create a Docker image, just call this, this, and this. However, there is a drawbacks for the native images, which we will see in the next video, because, for example, reflection won't work in native images, so you need to be aware. That's why I'm doing this video. I actually initially wanted to do it before the cloud section, but I just realized when you start working with data, such problems will already occur. So I'll just create this video before, and then I'll notify you when there's some problem with the, if in native images this won't work, so use this and this, right, or something like this. So yeah, that's there. Now you know how to create the native images, how to build them in a container with this flag, how to build the Docker image itself, and yeah, so and how to run it, of course. And you saw the advantage of the native images in a speed and the drawbacks of the build speed, but it's comparable if you use it like, you don't need to, for example, for dev environment, you don't need to use it to build it all the time, right? So you can always use GVM machine, you can use it, it builds super fast and you don't need to wait. But for example, for maybe staging environment, you might think about the even for dev, if your dev environment builds like every 6 hours or something, this will work as well. So one minute for dev environment is not so bad, but nothing stops you to use Java, which will be like in seconds, a lot faster than the native image itself. So yeah, we'll speak a little bit in the next chapter about drawbacks of the native environment and of the native builds, and yeah, I'll see you in the next video.